after we have performed demand analysis, we are able to characterize which are the main parameters of the demands, namely the mean, the standard deviation, the mode, the median, which is the coefficient of variation. If there are correlation between period, then as you see here, we have discussed the fact that time series can have also recurring pattern. In particular, that besides the variability that characterizes the demand and makes the demand crazy, behind this graph there can be some useful information that the forecast model should consider when trying to model and forecast the demand value. In particular, in determining the recurring pattern that can be hidden besides the data, the demand management technique try to separate two different types of components that is useful to identify. The trend, so the fact that longer, like on a long-term perspective, there can be an increasing or a decreasing or an increasing decreasing or a decreasing increasing trend during time. So the fact that there is first an increase, then a decrease, then an increase can be characterized through a trend components, and the fact that there should be a hidden seasonality, so periodical fluctuation of constant length. So there are periods in which the demand is systematically higher or systematically lower than the average. So let's start with the trend component. We've seen that to try to identify the trend component of a demand series, we can use two different techniques. The first one is the moving average. Which is simply given a time series, a technique that smooths the variability of the time series by getting the trend hidden in the data, by averaging key value of the series, where key is decided by the analyst. As you can see here, an order key moving average is calculated by considering the last key values of a time series. And in class, we have seen this example. So this is a demand 12 weeks or months, a moving average of key equal 3 and 6, is no other than in each period the average of the previous 3 value if the key is equal 3, or 6 value if the key equals 6. And you can see here, like, this value is given by the moving average in period 4 is given by the average of the previous 3 period, and the moving average in period 7 is given by the average of all the values from 1 to 6. If we represent them, you see that the moving average is able to smooth the variability which is included initially in the time series of the demand. And of course, the higher is the key, the step of the moving average, the higher is the ability of our series to get just the trend. You see the difference is that here you see like an increasing, a decreasing, and then an increasing again, but implicitly you see that the level of the demand is increasing like period after period. Even if you have like a downhill, like the level of the demand here is still higher than what you have here. Okay, so by calculating the moving average of higher step key, you are able just to get the trend component, which is an increasing trend, because you see that during time the level of the demand is increasing. You start from 650, you see, and you end with 844. So the moving average is telling that your series during time has an increasing trend. You see, there is an increasing trend of your data, and the higher is the key value here, the higher is your ability to be able to represent this trend. But also, as we've seen discussing class, is also higher the distance between the moving average and the actual value of the demand. Let's see how this translates in our San Pellegrino case. Doing in Excel is very easy because here I have representing, I mean, you can do that until 52, but as we discussed, it only makes sense to make it like for key value that are like in the order of 11 or 12, because otherwise you are including too many value, and of course the variability is moving too much. But doing Excel is very easy because if your moving average choose a key step equals 2, it means that you start from period 3, and in your period 3 your moving average will be the average between the value of period 1 and 2. Once you have done that, you just do the first, scroll down, and you see, just check that everything is correct. Yes, it seems to work. And you see that here, like you have in blue the demand and in orange the moving average. You see that with key equals 3. You scroll down, key equals 4, which means getting the first 4 value, and you scroll down, key equal 5, first 5 values, and I think that's it. No, we have also 6. Of the first 6 values. Then of course you can like go on in 7 and so on, but for the purpose of our analysis, let's just stick to 6. Now you have you see 6 different ways to represent the trend of the series, which again, in our case, is not well characterized because the data are affected by a large variability, a large randomness. So in this case, the moving average, which is from 2 to 6, is telling us that there is a clear trend. However, you can see that you step from 2, which has still a lot of variability but is still near the demand, to 6, where the variability is muted. You see a more clear pattern, but the difference from the real demand values are higher. So when choosing which is the best way to represent the trend, you need to solve the trade-off, and this trade-off is like depends on the attitude of the decision maker. If you are more comfortable in having a component that smooth a bit the variability but is still reflecting the demand values, you would choose 3 or 4. If you instead you are more comfortable with something that smooths the variability, so it's more like you see here, this trend is more like manageable and is more like smoothed and is more like linear, you will choose value like 6 or 7, and this will be the input of your to be given to your model. A second way to evaluate the series, the trend of the series, is what we have called regression. Again, I'm not revising exactly what regression is because we discussed it in class, but regression is a statistical technique that develops a line equation in the forms of y equals a constant plus a coefficient multiplied by x, where x is our independent variable and y is our dependent variable. We have, you see, we have recorded some value of x and y during time, and we want to calculate the estimated regression line that best interpolate these points, these observations that we have made during a specific amount of time. So once the line is developed, the x values can be plugged in to predict y, which is exactly what happened in the case of our demand. Because again, look at what happened here. the example. So this is our demand series, the month from January 2004 and April 2005. These are our periods. So this is what is called our independent variable, and this is what is called our dependent variable. This is the value of the demand. X is the time period for which we are focusing, while Y is the demand. This is, you see, these are, if you plot in a graph this point, 1, 202, 2, 325, and so on. The line, which is called the regression trend line, is the line that best represent the trend that is hidden in the data. And in our case is this equation, 188.55 plus 69.43 multiplied by the time period. So it means that this is the formula, this is the equation that links the time to our demand. And we can use this approach to get the trend which is hidden in a data series, which is the second alternative way to get the trend if we don't want to use the moving average. Let's see how it works. In Excel, simply, it's very simple, because again, as I told you, you don't have to use any particular statistical technique, and neither like to know which type of statistical approach you have to apply to calculate regression, because you simply plot your data. So as you have seen here, so you plot your data, okay, then add the chart element, trend line, more trend line option, display a linear trend, okay, display equation on chart. And I think it's not visible right now. I don't know for which reason. It's probably because it's not colored. Here it is. Okay. It was not colored, so don't like freak out if you don't see it, so just check the color. This is our equation as we have discussed in class. Y, the demand, equals minus 0.526 time plus 1106.6 unit, as displayed here. Now you can calculate what would be the value of the demand if you would apply this formula. Minus 0.526 multiplied by what? The time plus 1106.6. You do that for each period, and you have how the demand would look like if you would use this formula, which again, as I told you, is not like super accurate, because this regression trend line should get the trend which is hidden in the data, which is actually not present. If you see, like, this data doesn't show any type of trend hidden behind this. There is a lot of variability, so that's why this is a very smoothed decreasing trend line, which anyway like doesn't represent any specific trend. As I told you, in very easy, simple, and also in very in pool context, regression and moving average can be used to predict the demand also in the future, because again, you're just interested in understanding the magnitude of the demand, which is not the case on San Pellegrino because it's a make to stock and push supply chain, but imagine that they would be useful for the purpose. Today we are in the 52 week of the second year. If I want to know the demand of week 1, so 105, for here third, I just have to apply the same formula, minus 0.526 multiplied by what? 105 plus 1106.6. So the expected value of the demand tomorrow will be 1051.37. Same for the moving average. Like, as I told you, as we are using a moving average equal 3 as our benchmark, if I want to forecast the demand of tomorrow, how much will be the demand of tomorrow will be the average of the 3 previous value of the demand, so 1144. Again, these are two very simple ways to implement forecast model without the need of elaborating very complex and mathematical models. The problem, however, is now, okay, now we have two input to give to our model to calculate the trend of our series. The moving average key equal 3, so we of 3 step, and the regression trend line. Okay, so actually our problem is which one I would choose, and as I've told you in class, you should compare the error that they make in predicting the demand. So what you have to do is that this would be the demand according to your moving average with key equals 3. You copy this here, starting from period 3. Okay? Then you copy the regression values. Starting from period 1. Exactly. And now you calculate the difference in error that you make comparing the actual demand with the value obtained applying the regression trend line or the moving average approach, which means, of course, for the regression, different with the moving average key equals 3. Start from period 3, which means the actual demand minus the values that you would have obtained applying the forecast using the moving average. And from period 1, the difference between the actual demand and the forecast you would have obtained applying the regression as a technique. You have a series of errors made with the regression and a series of errors made with the moving average. What you do now, again, we will refine this approach in the following. The average error committed by the moving average is minus 3.74 unit, and the average error committed by the regression trend line is minus 0.01, so near 0. So the regression trend line is actually the best way to get the trend of your series, and you will give this equation as input for your forecast model. The second component is the seasonality. So given a series, like in this case you are talking about a trimester, so you have 3 years and 4 values for each year, we have this type of series. So it's Kinder Brioche, which are this type of snack, which are distributed in this way. Okay, of course, I leave it to you which is the level of aggregation. So remember, you have here trimester, the demand of Kinder Brioche in north of Italy. So you have been able to ask yourself which is the level of aggregation of this type of demand, but I leave this question to you. The question is there seasonality in this series? To do that, because the data seems to have a cycle of 5 periods length, so you see that after 4 periods, 1, 2, 3, 4, like some cycle seems to be repeated. So it makes sense to ask yourself if there is seasonality. To understand that, you can use what is called the average method or the seasonality coefficient method. So the first step is calculate the average demand in each cycle. So you see here you have 3 cycles. 1, 2, 3, 4 values for each cycle. Okay? You calculate the average demand in each cycle. So the average demand for year 1 is 8,225. The yearly demand, the average demand of year 2 is 9,608.5. The average demand of year 3 is 10,921. Okay? Then, once you have that, you calculate the seasonality coefficient specifically for each demand in each cycle. So you see here, and we have seen in class, that this value is no other than the ratio between the value of the demand recorded in the year and the average value of the demand. What does it mean? It means that in this period the demand was only 65% of the average. Here, the demand, so lower. Here, the demand was higher than the average because it was 1.25 higher than the average. Here, instead, it was near the average of the year 3, which makes sense. Yes, because the average demand in that year was 10,921 and the demand in year 3, trimester 4, is 10,990. Okay, so now what you have obtained is that for each cycle, okay, for each period of each cycle, you have a specific seasonality coefficient. But now my question is, remember, the objective of the seasonality coefficient approach is telling me for each significant period of your series, that in our case is every 3 months, in the case of San Pellegrino is every week, is the demand systematically lower or higher than the average or near the average? Here what you have are specific seasonality coefficient for specific value of this period of the cycle. To find which is the seasonality coefficient for each period in each cycle, you have to average the value of the seasonal coefficient that you have calculated with the previous step. So the seasonal coefficient of the first 3 months in each year is no other than the average of the seasonal coefficient of the first 3 months that you have recorded in year 1, year 2, and year 3. Okay? Which means that according to our data, remember, these are like sample driven, okay? If we had a 4th year, this may be different, but according to our data, in the first trimester, the demand is 33% lower than the average, because again, you see here, like the demand, the seasonality coefficient is below 1, 0.67. In the 3rd trimester, instead, the demand is 31% higher than the average because the seasonality coefficient is 1.3. So 30%, 31% higher than the average. So if your question is the demand systematically higher or lower than the average, your answer would be, it is systematically lower than the average on period 1 of the cycle. It is systematically higher than the average on period 2 of the cycle, on period 3 of the cycle, and on period 2 and 4, instead, the demand is around the average. Let's see how this applies to the Nestlé case. This is like the procedure is very straightforward. So the first stuff that you have to do is to like put near each other value in the same cycle, in the same period of the same cycle, which means basically you have 52 weeks repeated for 2 years. Okay, so what you have to do is to do this, this, and this. Now you see, for week 1, how many values you have? 1 and 2, 94, 90, 50, and 0. For week 2, how many value do you have? 90, 912, and 900, and so on. So you have put simply near each other value in the same period of one cycle, which is 1 year for us. Okay? Now you need to calculate the punctual seasonal coefficient. Sorry, first you have to calculate the average demand for each cycle. So average demand of year 1 and average demand of year 2. Now you can calculate the punctual, the specific seasonal coefficient of each period in each cycle that are included in your demand series sample, which means dividing the demand of the period with the average demand of the period. Remember to put the dollar to block this value, because then what you can do is doing that. So in the first period the demand is 12% lower than the average. In the second period 60% lower than the average. In the third period 22% higher than the average. Here 70% lower than the average, and so on. When it is 0, it means that the demand of course was like 0. Okay, so there was no demand. You do the same here, remembering to change the average value of the demand. Now, for each period, you have a specific seasonal coefficient. You want to have, again, if I take week 14, I want to know if the demand is systematically lower or higher than the average, and I have two values of the seasonal coefficient. How can I say about what can I say about this? On average, what's happened? I simply make the average between the two values that I have. So to obtain the seasonal coefficient of the period in the cycle, not specific, the average, I make the average. And they are displayed here. Now, the question could be, again, also in this case, the discussion can be subjected to the sensitivity of the analyst. But the question is, of course, this shows that there is not a clear seasonality or clear path. But if you want to find something hidden in the data, what you can see is that there are two periods from week 27 to week 30, and from week 41 to the end, well, the demand is first systematically higher than the average. So from week 27 here to week 30, you have an over seasonality, so demand is systematically higher than the average. And then you have, if we exclude this outlier, which is 1.04, you have from week 41 to week 52, so at the end of the year, a demand which is systematically lower than the average. So it means that you will have an under demand compared to the average. So these are the only considerations you can infer after having analyzed the demand in terms of the seasonality coefficient and the seasonality component. So if you want to give an input something to your forecast model, this is what you should say. If you want to say something from week 27 to week 30, you have a demand which is systematic, value are usually higher than the average, while instead from week 41 to week 52 you have values that are systematically lower than the average value of the demand.